and our topic is social robots. So social robots have been a focal point of science fiction movies for many years now, but what exactly do we mean when we call a robot a social robot? A definition by Wikipedia states that it is an autonomous robot that interacts and communicates with humans, following social behaviors and rules attached to its roles. Now, these robots are not just robots that can automate a task or do a job that's particularly dangerous or dull, but rather a robot that is designed to have social interaction with human beings. So in this figure, the robot denotes the physical embodiment of a robot, and the social interface denotes the social expectations of the robot in a social settings. Now, some examples of social robots is Pepper, which is the world's first social humanoid robot able to recognize faces and basic human emotions, and Jibo, which is an AI that attempts to build relationships with its owners through facial and vocal recognition technology. And he also has an AI that follows the user around when they talk to him and with a 3-axis motor system that allows him to see 360 degrees. Some characteristics that a social robot could have be artificial senses such as vision, hearing, and touch, and perceptible responses such as movement or speech or sound. And arguably the most difficult part is its interactivity with its environment and manner of movement. And ideally, the program would combine the comprehension of language with nonverbal cues to determine the most appropriate way to respond. Now I'll pass it off to Marcelina to talk about the current research.
Thanks, Danny. There's no question that social robots and other AI systems are becoming a growing presence in our lives. There's a plethora of research being done in this field, and the current goal is developing robots that will support people in their daily lives. One growing area of social robot research is in healthcare and special education. There are a lot of current studies on social robots interacting with special needs kids and how they may help them develop socially. And there's also research in how social robots can perform as companions and even therapists to people like the elderly. Beyond this, there's a lot of consideration into the ethics and emotions behind social robots. Designing robots that understand people is really only half of the equation, so developers also have to consider what features robots will need for people to trust them and want to engage with them. So there's a lot of research into how we can design social robots in such a way that makes it feel like we're interacting with someone instead of something. And these main areas of current research are serving to overall create more emotionally capable social robots that will be easier and more beneficial to integrate into our lives. And now I'll pass it off to John to talk about some advantages and disadvantages.
There are several advantages, disadvantages, and ethical concerns related to social robots. For advantages, in an article published by the American Psychological Association in 2018, titled The Dawn of Social Robots reduces loneliness and improves mental health, relieve pressure due to gaps in the social care / customer service workforce, and allows children to practice social skills. For disadvantages, in an article published by The Guardian in 2020, titled Robots to be used in UK care homes to help reduce loneliness, their initial costs are higher than the average salary of a care worker. And children may confuse robots as people, causing ethical implications, and poor implementation of code can be frustrating for customers / users. Now, to Andrew on design-related difficulties.
Yeah, thank you. There are about 3 main design-related difficulties that we'll touch on today. The first being that these are simple to prototype, but complicated to manufacture. With advancements in 3D printing and commodity electronic parts, prototyping is easier than ever. However, when these robots are placed into manufacturing roles, there's trade-offs that are had to be found between price and performance. For example, a company with over $150 million from investors still is comprised robot of 360 parts that's crammed into a very tiny robot and makes manufacturing very complicated. Another difficulty is avoiding the uncanny valley with social robots that represent humanoids. This was a term first identified by Mashiro Mori in 1970. And this is where humanoid figures that are almost human, but are just a bit off, are perceived as creepy and revolting. As you can see to the right, this is a diagram of that chart and how human likeness adjusts as familiarity to a human increases. And then finally, challenges of artificial intelligence. So the concepts are very difficult to understand and translate into code. And furthermore, algorithms can demonstrate biased results when they're created by developers with biased minds. And now I will translate it to Charlie, who will speak on code implementation.
Thanks, Andrew. So for this is just a pretty simple application of Google's Speech API, which is a very complex AI that allows us to take our own audio input and output it to string text, and then have that played back as audio to us. Now on the left in the code, you can see just some simple variables initially created, and then the meat of the code, which is a infinite while loop. That just takes our audio and puts it back to us as a string. Now, one of the most important pieces is the if loop at the bottom, or the if code at the bottom, because we can add interactions such as if it hears us say, close garage, we can connect it to a garage and close that. We can do this with lights, we can do this with thermostats. So that's a very important application for the actual robotic portion of it. Now moving on to applications. So a simple application is the Coca-Cola Freestyle machine. Now, you may not think this is a robot, but it does have moving parts, and it interacts with people using a touch screen, and its output is a filled soda cup. It's pretty simple, but it's a simpler application of the robotics portion that you've seen before. Another example of this is the self-service kiosk at McDonald's. In the same way, it also senses its environment using a touchpad, and it prints receipts, and then it will actually give the orders to the workers. A more complex application of robotics would be something that a lot of people have, which is Alexa or Google Home devices. Its background is a very complex AI that interacts with people and outputs audio back to those people in response to their audio inputs. And it can also interact with many other moving systems such as garage, lights, thermostats, etc. That was our presentation for social robots. Thank you for your time, and thank you for listening.